Hello and welcome back to this channel, and in this video we are going to conduct one small mock interview of one of my students who have been teaching Python and little bits of machine learning for the past 1 month or so, or a little bit more than a month. And he's going to face one of interviews in some companies, and I'm gonna just help him practice his interview skills. And in this session, we are going to show how he can completely implement one ML training code from scratch, using one of the datasets he could find online. And we will just discuss how to go along, correcting his errors, and so on and so forth. So without further ado, let's get right into it.
So basically, I was doing one of the prompts, and I was trying to make like a basic CSV writer. And so I basically like kind of laid out like very bare bones steps of like what to do in like a Jupyter notebook, of like how to set up like a CSV folder, like format it, and then make an X and Y, and then um use like random forest regressor to like make a model, and then use that model to create like a confusion matrix, and then also give like accuracy score with like percent error. And so like I just wanted to be able to do that from scratch. And so like I have like the like bare bones things written out like on a notebook of just like, it's not like the exact code or anything, but it's more of just like number one, like load this thing and like import pandas, and it's like kind of just like written out in words, but it's not like the code itself. So I was thinking like I could just like try and use that and like like see like how that goes, because I'm not sure if I could like like right away just like create something like more complex. But I feel like the more and more I do something like this and like a different project, like it'll be more natural. But after like kind of like setting out like these parameters, like like maybe like a few, like it made it a lot easier.
Yeah. So you are doing that CSV writer thing and also practicing with the random regressor and the other ML models. So that's
Exactly.
yeah, that's
So
that's
I
actually
just
good
used like the
practice.
iris model.
Mm-hmm.
Like that's like already loaded on like sklearn, I'm pretty sure.
Yeah. That Iris dataset is already loaded there. Correct.
Yeah. All right, so then I'll just start with like a new one. Code. So let's just okay. So this is just all right. So first, I'll start with.
So your screen is not being shared, so I can't see.
Okay. Sorry about that. But I thought it still was. Can you see this?
Okay. Yeah, I can see.
So these are just like all the ones I'm probably gonna use.
Yeah, you can turn off the GitHub completions and that thing. It might.
Do that.
Yeah, you can do that. Like there's this icon beside prettier, and there is that can turn it off. Turn it off. Not this one. On the left side of it. On the left side of prettier. Yeah.
This thing.
Yeah. So what's this? This is flexi plot. Yeah, you can disable completions right there.
Okay.
Yeah. So now it won't pop up. Just press escape. Yeah.
And then matrix.
So one tip while you are doing this, even in front of the interviewer, is whenever you're typing any line of code, you should be explaining them, whatever it means.
Sure,
Yeah.
Okay, so I'll just explain like what I've done so far. So sklearn, like the iris data is like the just the public data set for like, the pedal length, like sepal length, and like those things. And then pandas is like for the CSV, right? Or like for the data frame. And train test split is like for like the model itself, like how I'm gonna like split up the data into like two like different like training sets and testing sets. And then sklearn ensemble is for the model itself of like what I'm gonna be using to like actually create the predictions. And then now I'm gonna add the sklearn metrics with like accuracy score and the confusion matrix. So that's in metrics, right?
Yeah, that's in metrics, accuracy score.
Okay. So there's that. And then NumPy. So and then yeah, so these are probably all the things I need to import, and then I could load the iris.
Yeah. So keep saying whatever it's coming up. So yeah. So this takes practice a little bit, yeah, but you have to do it.
Yeah. So this first one, I'm setting like iris to just like load it and like load the information, and then this next one I'm making like a data frame out of it. So yeah, like this data frame is gonna be like kind of like what I base like all of my like information off of. And yeah, that's like how I'm gonna make my target array. Wait, so I would put like, would I put like the CSV file here?
Not really, but
It was like
yeah.
What goes here? It's like,
so here usually you don't put a CSV file because you're not importing a CSV file. You're getting the iris data from the data set. Yeah.
Okay, it'd be like iris data.
Yes.
And then I'm sure there's like some other stuff.
Yeah, some other things are there, but it's okay. It doesn't have to be accurate. You just have to explain the what's going on in your head and how would you actually import it. Your code does not have to be crystal, accurate from start. No one expects that. Like you can find that in the documentation.
So there's that, and then I need to make the target array.
So what's the target array is gonna do? What's this target?
So the target array is like that's like the y variable where it's like all the columns that is not being used for data, and like that's basically like what you're trying to predict. Yeah. And so like the non-target array is like kind of all the information you're going to be using to like guess the target array.
Yeah, so this is the labels and the other one is the features. Yeah.
Yeah, so I'm trying to make it like this like target thing, and if I remember, it's like something like this. Like I don't know, is it something like that?
Probably. I'm not familiar with the functionalities of the built-in datasets. We can just check up the documentation for it, but go on. Like imagine that this is working, okay? And go to the next step of the implementation.
Okay, so then iris species. Oh yeah, I create like so this one like this line before like is like the target one, and then this next one I'm trying to like sort like how the data would be like into like where instead of like the names of just each of the like pedal or like the target values, like I want to turn them into integers like 0 and 1 and 2 just to make it like more simple.
Okay.
So
okay.
It was like that. and then it's like iris something, and then I remember it's like map, and then you kind of like make like the dictionary values, or like 1 would be 0 would be
Yeah,
what's the
yeah.
names of them? Like Setosa, like this, those, but yeah, like
Okay, I
so
understand. All
basically,
right.
yeah. So this is just like a dictionary for this thing, and then so now I could create my x and y variables.
All
So
right.
x say equals so that would be all of the data except this column, because this will be like the target column. So,
Okay. So how would you do that? Like, this is a very crucial step. How would you select that?
yeah, so it'd be like iris data, and then dot drop, and then I'd do columns equals species. So yeah, so basically this one would be like, it'd be all the data except the target value, which is species, and then I would set y to just species itself.
Yep. Yeah. Okay. Cool.
This is like the x and y variables, and then so now this contains like, you know, sepal length, like the length of like the flower, like, and then all of that, and then this y is basically like the type of the flower. And then so now after I make that, I could start the train test split.
Yep. Yep. You can now start the splitting of the data.
Yeah. First 1, 2, and then
Okay, so what's this test size 0.2 that you're putting in?
so basically, like, I created like my training and testing sets, and then I'm using the train test split that I imported before, and so I'm setting it to like the x of this, and then the y of this, and then the test size is basically like I'm taking 20% as like my testing like set out of like the entire data set. So basically that would be like the x test and y test is basically like 20% of data, while train is like the 80%, and like that's what's being used for the model to like predict it. But the test is like, you know, being used to like kind of like compare with those like the predicted values.
Correct.
Yeah.
All right. Cool. Go on.
So there's test size, and I'm pretty sure there's something after to make it like, I don't know, like work better. And then I'll make the model now. So model equals random first classifier, and then so I could change the amount of trees using n estimators.
Okay.
So let's just say like, you know, 100. So that means that it's gonna go through like 100 trees before it gets to its value. And
So
then
what do you mean by trees over here? Like what do you mean by trees?
so that's like the different routes it could take to get to like the final answer. So like the more routes it has, like the higher probability it has at getting like higher accuracy, and like the lower routes it has is like, you know, like the lower logic, and like it uses like less like data branches to get to like, you know, like a high quality prediction.
Yeah. Okay.
So then do I do the index here?
No, for random forest classifier and estimators is fine. Yeah.
Okay, yeah, so n estimators, and then I fit the model.
Yep.
X train, yeah, so X train, Y trains. Yeah, so I fit the model using the train values, and then I make the prediction Y. Yeah, so the prediction value uses like a prediction from the X test values, and then so with this Y prediction, now I could compare like Y prediction with Y test, and like I could get like a confusion matrix with that.
Okay. I saw that you removed that confusion to and change it to conf. Why do you think you did that?
So I just wanted to make sure it didn't mess up with like the actual function itself, like confusion matrix, like how I import it here, because that's like more of a
good.
Okay, and then oh yeah, I also want accuracy. So accuracy score, and then do the same thing. So yeah, now both of these things are creating like final outputs using for one is going to make a matrix with like the false positives and the true positives and everything, and then the accuracy one is going to be like more of a percentage of like exactly how much. And so yeah, I could do percent error with this. Was it's like 100. So it's going to be like 100% minus the accuracy score from here, because this accuracy score will give like a value from like 0 to 1. So I just need to multiply by 100, and then if I subtract it from 100%, that would basically be like how much is like the percent error. And then so I could just maintain. So it's like accuracy. So your I would do the so then I'd format it to only have so like this is like the original value, because it would be like some value maybe like 0.9375, and so I wouldn't want like that long of a number. So this like decimal is to like to show like it's like a formatting instruction, and then this 0.2 is or
just up to the 2 decimal positions, the precision.
Yeah, so it would stop it after 2 decimal positions, basically. Or wait, yeah, and then this just formats it to F, and then so I'm gonna do the same for the confusion matrix.
So confusion matrix.
Like,
okay.
Yeah, I could just paste just like that.
Okay. Yeah.
And then oh yeah, for the percent error I need to do this again.
Okay. I see what you did. Okay, that's good.
Change that, but I think there's gonna be some like issues with the functionality, but I'll just
there's gonna be some issues. The first thing is there is no such thing as iris data in sklearn. Okay, there is the iris data. Okay, you have to import data sets. You have to, and then from inside of data sets there is that iris data set. So it's like a library kind of scenario, and then inside of that you have the iris data set. Okay,
so should I just do data sets, like import data?
Yeah, so if I see the documentation as well, the way to solve it is, first of all, you basically have to import data sets, okay, from sklearn import data sets, and then you have to do like iris equals to datasets dot load iris. So that's what you have to do. So let that be, and then here equals to iris equals to datasets.loadIris.
Like this.
Yeah, exactly. So now you can have that, and I also implore you to see now no errors. So you should print out at every state. For example,
Yeah.
if iris is getting loaded correctly or not. So like that. So if you run that, you're gonna have lots of errors because of this yellow squiggly lines right now, right?
Yeah.
So yeah. So if you want to solve that, then basically what you can do here is, I think, if I see some implementations online, I see what they have done with this is basically xy equals to datasets.load arrays. That's done. Yeah, so we don't have to get that df like that here anymore. Okay, what you can do, load
Yeah.
iris already has that function inside. Okay, so instead of the
Yeah.
iris, you can just type in x comma y. No, not here, the first line, the line before that. Yeah, here instead of iris, and not inside there, instead of iris as the variable, you can just type in x comma y.
Like right here.
No, at the beginning of the line. Yeah, here x comma y. So they have that functionality as I see here. And then here in load iris, you can just say, I think, return xy equals to true, something like this. So inside the parenthesis of load iris,
Yeah.
inside of that, so you can say return. Yeah, see. Go back. You will see that. I mean, like erase it a little bit. You will see the suggestion. Return. See this one. Click on it. Yeah, then say it to true. Yeah, basically set it to true, and you don't need the rest of the lines anymore, so you'll already have the x and y.
So
Okay,
then what
but
about like
so what you did was also fine. There are several implementations. The one I'm looking at, so load iris already has that built in. Okay, what you did is important
yeah.
because if you have a csv file, that's the way you should do it. There is no other functions for that. Yeah, because this is a built-in data set, so it already has those
So
functions
should
built in.
I set it to a CSV?
No need,
So
no
I could
need
do
to.
that, right?
Um,
Okay, yeah then.
yeah, let it be. So x and y. So you can see that it completely eliminates if you're using built-in datasets like this, the use of
Yeah.
x and y. But yeah, this is the way. What you did here, it's correct. Okay, just not for our scenario. All right, because you're using built-in
Yeah.
datasets. Yeah, so this is fine. That I really that dot drop columns equals to species, and then columns equals to species. Those two are correct lines, but only if you have a CSV. Okay,
Yeah.
so that's one thing. So you can just comment it out. You can keep it. You can comment it out, like select them and then control forward slash. No. Control forward slash. That's what you have to do. You can close it.
Okay, right. This. Let's do this.
Yeah. So yeah, there. So it's commented out. So now the thing is here, the rest of the things should work perfectly fine. Here, just y test, the variable name is different, so you have to put capital, and here you have small letters. So that's it. Just change it on the red squiggly line. Go scroll down. Yeah, here.
Oh, here.
So
Okay.
yeah,
Yeah.
so
Oh,
it's
okay.
capital. Same thing for accuracy, and then. But ypred, I think you have put small letters. So see,
Okay. Yeah.
yeah, that was fine. Yeah, I think it should work just fine now. There. So accuracy score is 0.9.
So what is this? This confusion matrix is
Okay, yeah.
not
So
working.
confusion matrix, the way you should print it is, I think, I forgot how to print. Wait, it should work, right? Confusion matrix,
That's what
print
I was
out.
thinking. Like,
Yeah, it should print out. What's going on over here? Confusion matrix, y-test function confusion matrix. Why? Oh yeah, you are printing out the function of it, right? You have to print conf matrix.
To do like conf. Okay,
Yeah.
I get that.
Yeah.
Okay.
There.
Or there.
Yeah.
And then so that looks pretty decent. I guess I could maybe like get a different thing, like changing this. Yeah, so I could kind of like change the accuracy and stuff to make sure it's not like overfit or anything.
Yeah. So that was too much. Yeah. So 100 is like too much.
Yeah.
5 is enough for our scenario over here.
Yeah, for this data set, considering like it's pretty like simple and like there's simple
exactly
stuff to do with it.
All right.
Okay.
So
yeah.
So what you did was pretty good. I mean, you managed to remember all the steps. The one step that we did not need here, and neither did you do, is feature scaling. Okay, so I'm not sure if our dataset required it, but I don't think so. But we did not do that here. But once again, it's okay. It's okay. So let's see. We are at. I think we still have 15, 20 minutes more. Would you be comfortable if we go into a little bit more formal kind of interview scenario?
Yeah, like questions or something?
Yeah, questions. So
yeah.
So we're gonna keep the VS Code open because we are going to use it. Okay. So usually what happens is you start with your introduction. So so let's just go with the formal route. Like, tell me something about yourself.
I enjoy exercise and yeah, I'm a computer engineering major. And yeah, I'm in California right now.
All right, that's great to know. I'm just trying to become very. Okay, so let's get right into the questions here. So I have some basic questions in front of me that I just wrote down just before the meeting. So tell me, what is machine learning or what is AI? What do you understand by it? Like one of the most basic questions. You might be asked this at a real interview.
Yeah. So I feel like I would say like it's basically like you're given like a very large data set and it like helps to like simplify it using like a model that already exists, which like uses like methods like this, like train and test, and just to split up the data, and like you could use like predicted values to like compare to that, and like that's how you could create like more and more accurate predictions, like just looking at like your accuracy. And I would say like that's a lot of like what machine learning is for, is just like simplifying like a lot of like redundant data that like humans shouldn't need to do, and then you can use like simple like code and machines like this to like do it instead of like like counting each one individually, and you could just make like accurate predictions like like that.
Okay. So, a little fun question for you. What would you say to someone who does not understand like machine learning or AI, but just knows what it is and says like it's magic or something? It's magic to the person. What do you say to that person?
So I would say like instead of it being magic, it's more of just like a really like accurate guess. And so like it just uses like all of like the data you provide it and creates like kind of a guess based on that. But like the more and more like specific the model is, and the more um let's say specifically for like a model like random forest like classifier, it uses like a bunch of trees until like the most accurate tree like branch is like found to where it's like the most efficient path. And so basically like you're just trying to use the most efficient path to get like the best guess. And like once you get like the best guess, it seems like it's almost magic, but like in actuality it's just like the program itself like creating like the most like efficient method of like finding the answer you're looking for. And like more and more like the higher end like learning models such as like ChatGPT and stuff like that have just like a lot higher quality models that, can create like extremely accurate guesses. So it almost seems like, you're talking to the model itself.
That's a very good answer, actually. That's a very good answer. So you mentioned ChatGPT, right? So ChatGPT is not just one of your mobile game applications or something like. Oh, and obviously, as you said, it's basically not magic. So if you were to build something like that, a complete end-to-end machine learning model kind of scenario, like how would you go about it? Like, what is the architecture or how is it structured? Can you explain? Like, how does it work?
Like ChatGPT itself.
Not ChatGPT, so something like that, an ML application that basically predicts something. Okay, how would you go about into making it?
So I would start with just creating creating like a outline, like something like this. And then, I would first like kind of like understand like what specific data I'm being provided. Because if there's like a specific output like a user wants, like, they want like, a certain species, or they want like a certain estimate, or they want a yes no answer, like you kind of have to like tailor your model specifically to that. And like if it's not, then like, you're gonna get like worse and worse results. So like you kind of like need to first see like the data you're getting, and then base your model off of that, and base like what method you use to like split the data like off of that, I would say. And yeah, so like it just, I feel like it's like case by case, like what like method you would use. But you should just use like the one that's like simplifies it the most, and where you could get like high accuracy, but it's not like too like overfit and like over accurate.
Okay. That sounds very reasonable. So let's say you have the model ready, right? So you have your model ready at
Right.
you, or someone else made it for you. Everything is fine. The model's predicting great. How would you make the application now? Because that's just the model, right? We have a model right here in front of us. The user is not going to interact with this, right? It's just code.
So I would just create like a simple, probably like Flask application. So that's like a built into Python. So you could just like download the Flask, and then you create a Java file, and then you create a CSS file, and then in the and then you also create an HTML file. So basically, you on the HTML file, like you format the HTML, and kind of that's like where you could use like methods like Tailwind CSS to like use like more like higher quality formatting, and you could add colors and more specific things just to make like the presentation nicer. And then after that point, like after you set up the HTML itself, you could load the model into the HTML, and then uh, you could create another like Python file that basically like runs that whole like HTML and the model within it. So that'd be
Okay.
like basically like how I'd start to go about it. And then, I would use the Flask application it would open up like a kind of like a testing environment on my browser, and I would be able to like kind of interact with it and be able to like tweak it and make it, better based on that.
Okay, that's good. So you'd be making a Flask application. So that's like a web application to
Yeah.
actually interact with the model. And yeah, so the Python would actually load the model, and you would use your HTML, CSS to interact with the model and get the results and show. So yeah, good. That's good. So have you done any projects regarding this? Like, do you have any relevant projects that you have done
So
recently?
yeah, so I have a machine learning one where
Mm-hmm.
I set up a machine learning like simple website to check with like 50 startup companies.
Mm-hmm.
Or no, it was like the social network ads, and or it was like some income thing where it's like you guess if someone bought something based on their income or not. And do you remember what that one was called?
Yeah. It was social network ads, basically.
Okay,
So
yeah, so
based
it's
on
like
the
social
ads,
network ads.
yeah.
Yeah. So it was like, yeah, based on the ads and the age and some other information, like would they buy like it, like, and it was like a 0 or 1 value. So basically like for that, like um I created an HTML like to format it, and then before that I had to import like the model itself for the regressor, and for the model like on the Jupyter notebook to use the regressor. And then so on the Jupyter notebook initially you have to split the data and train it, and then create predictions. And then after that point, once you have like decent predictions and like a reasonable accuracy score, you could then like import that into the HTML file. And you could use like methods like Tailwind CSS and stuff to make it more like presentable. And then after that point, you would use after you would see like the model kind of like on the website and functioning, and you could see like your output of like a confusion matrix and your accuracy score like on the like website itself. Then you could start to like use test values and kind of like use inputs, because like on the HTML website itself, like you should be able to set up like the name and like format it, and then create like a text box where you could enter stuff, and then create a enter box right under where you could click it and like enter that value. So within that text box you would put in like a realistic value. Like if you put in something way out of the range, that's an outlier, like realistically you're not going to get a good guess. So you would kind of have to, not like you have to see the data to create an answer, but you have to create like a reasonable guess, and then based on that, like it'll give you like a confusion matrix or an accuracy, and like how close of a prediction it is. And yeah, so with that, like you would have like a simple machine learning model that like guesses based on like an inputted value. But obviously there's limitations to it, as like if you put in like unknown values or letters or something, like maybe it'll break down and it won't have any like kind of like error stopping situations. But other than that, like for like if you put in a correct value and it's reasonable, like you will get out like a decent prediction.